good, Gayatri. You guys are able to hear me, right? आप ऊपर ही अच्छे थे. अच्छा, अच्छी ऐसी बात है, कोई बात नहीं यार. Doesn't matter. You have separate. Natarajan, there is a YouTube channel named Unacademy Computer Science. Yes, over there I take lots of sessions. Okay, your teaching style is very good. It is easy to understand. Thank you, Vaibhav. ओके, चलिए शुरू करते हैं. बिल्कुल 2 मिनट लेंगे, बाकी लोग थोड़ा सा रिलैक्स्ड हो जाएं. एंटायर थिंग एंड सैटरडे एंड संडे टेलीग्राम. व्हाई आर यू सो भीमा? आई एम नॉट टेकिंग लेक्चर्स ऑन स्लो स्पीड. आज पीवाईक्यू क्लास लेंगे. हाँ जी, बिल्कुल पीवाईक्यू क्लास होगी 4:30 पे. विच सब्जेक्ट आर यू गोना टीच आफ्टर दिस? डेटा. Those FAQs are for everybody. Whoever wants to learn for GATE or go for GATE preparation. Problem with the quiz, actually, the team has scheduled the quiz and the class at the same time. We will have to check out how we can make it. I give my GATE exam in second year. No, you cannot give your GATE exam in second year. You will not be allowed. If you will fake like you are in third year or something, you will be caught next year, and might possible they will expel you to write GATE exam further onwards. So please do not try that. Do not take risk with your career. People are writing GATE exam in second year itself just for experience. Should say going to pass in 2020 computer. COA at 4:30 p. Two section take only 3 courses. Inside the PPT. Will you start seeing all questions that you saw? Just select only one thing in your control as learn and learn. Focus. No any faltu ki baatein. A placement just because GATE will not be assuring your career. You don't know if you'll be getting the great rank in the GATE exam or not. No. The person who is topping each and every, you know, quiz, test series, everything can get less marks. The person who is not getting enough marks in the quizzes and test series, etc., can get more marks in GATE exam. So we don't know, it's totally uncertain. So have a plan B for sure. Plan B is and should be there. I also have taken one placement so that my future will be secured. If I'll pass out next last class, I am done up to a certain level, then only I will be looking for your questions. Cool. Fine. Last class, I told you CPU scheduling does what? It makes a selection. Selection of what? Which process to run in CPU. What is the goal of CPU scheduling? First, we need minimum waiting time for the processes, and each process should spend minimum time in the system. So whenever it arrives in the minimum spent time total, it should terminate, it should complete its execution. Then second is we need to have CPU utilization increased. And third one is fairness. What does it mean by fairness? Fairness means it should, the CPU scheduling algorithm should give the fair chance to each process to run. It should not happen that few type of processes are running, and some type of processes or some types of processes are just waiting. Like in your childhood, when you were playing some games or cricket or something, you were having some players who are not getting baiting, right? Who are not getting bettings, right? Why? Just because they were not good enough. So that was not a fair deal. Every player should get enough chance or fair chance to bat. Okay, cool. Now scheduling algorithms type. There are two types of CPU scheduling algorithms. The types are very simple, which we have discussed already. One is non-preemptive, another one is preemptive. what does it mean? If any algorithm, oh, kahan chale gaya main? If any algorithm selects a process to run, then until that process completes or terminates, no any new process can be scheduled. That is non-preemptive scheduling. With that process come, oh, kahan chale gaya main? If any algorithm selects a process to run, then until that process completes, or terminates, no any new process can be scheduled. A process to run, then until that process completes or terminates, no any new process can be scheduled. That is non-preemptive scheduling. We discussed about this already. Or terminates, no any new process can be scheduled. That is non-preemptive scheduling. We discussed about this already. What is a non-preemptive execution? And preemptive is what? Until a process or whenever a process is even not completed, not terminating, or not leaving the CPU by its choice, or whenever a process is even not completed, not terminating, or not leaving the CPU by its choice, then too we can stop that process in between because of some factor. Not terminating or not leaving the CPU by its choice, then too we can stop that process in between because of some factor. What are the factors? Based on the algorithm, we will select the factor. If you guys are aware of priority algorithm, then we can select a higher priority process to run next by stopping a low priority process. By priority algorithm, then we can select because of some factor. What are the factors? Based on the algorithm, we will select the factor. If you guys are aware of priority algorithm, then we can select a higher priority process to run next by stopping a low priority process, by preempting a low priority process even before it completes. That is the reason. Priority is the reason. Yes, there can be multiple reasons. So what assumption we are going to have for all the factor? If you guys are aware of priority algorithm, then we can select a higher priority process to run next by stopping a low priority process, by preempting a low priority process even before it completes. That is the reason. Priority is the reason. Yes, there can be multiple reasons. So what assumption we are going to have for all the execution, whatever the execution we are going to learn in the future for next 2-3 days, the assumption is all processes have zero IO requirement. No any process requires the IO. No any process requires the IO. Zero. Requirement of IO is zero. Means if you remember the graph, which one? State transition graph. Ready, schedule, dispatch, running. From running, there were 3 transitions out. One was exit, so that the process can terminate. One was preemption, so that process can take the transition to ready state again. And other one was IO. But this going for IO is not an option. So I'm saying for all the assumptions, this will not be a possible transition at all. ऐसा होगा ही नहीं. This will not be there. So what happens? A running process can leave the CPU now in only 2 choices. One is if it is completing, terminate. If it is not completing, it can leave the CPU because of preemption. Now you are confused. Why so, sir? It's just an assumption I have written over here. Now you'll say, sir, agar aa gaya to? If I am saying it is 0, then how can it come? And if it will come, then I will explain you what to do. Abhi to assume karo. Right now to you assume that no any IO requirement. Okay. Then if no any IO requirement, this is not the transition. Only 2 transition possible out from the running. Either process is terminated, leaving the CPU, or process is preempted, then leaving the CPU. In non-preempting, we will be having even single transition out, which is exit. Why? Just because this will not be there. You remember? Yes. If you don't remember, I will come through this camera at your house and slap. Okay, चलो आगे बढ़ते हैं. Before we go for scheduling algorithms, we need to know some kind of times related to the scheduling. What are these times? These are easy things, very easy things. Arrival time. Arrival time is that time at which process arrives in the system. Means whenever process is actually admitted. At what time? On the timeline. First time. Then that is its arrival time. It's like, suppose you have a college. Assume you will have to go to college and you have a college. Okay. Now, if suppose you are arriving at 8 a.m. in your college, then that is your arrival time. Your friend is arriving at 8:02. One of the friend is arriving at 7:59. One of your friend is arriving at 10 a.m. So these are the arrival times. At what time you are arriving in the college? That is the arrival time. Process arrives at what time in the system? Arriving means it is admitted by the long-term scheduler. Next. Now, when it is arriving, directly it is going for run? No, it is not going for run. It will be in the ready state. Among multiple ready state processes, the scheduler, short-term scheduler, will select one process to run. But when a process is scheduled to run, for how much time it will run on CPU? Total time required by a process to run on CPU is called as its burst time or service time. So, total amount of time a process requires to run on CPU. That is its CPU burst time or service time, BT. I will write in the short as BT, arrival time AT, burst time BT. Now next is this, I will talk about this completion time. Suppose you are coming to the college at 8 a.m. and leaving the college at 4 p.m. So 4 p.m. is your college completion time, a time at which process is completing execution. Got it? Now, if you are arriving at 8 a.m. in the college and you are leaving at 4 p.m. the college, total how much time you spent in the college? How much time total you spent in the college? 8 to 4. 8 to 4 is total 8 hours. How can you easily calculate? You can calculate 8 to 4 p.m. in the 24 hours. You can write as 16, right? 8 o'clock and 16 o'clock. 16 minus 8, 8 hours you spend total in the college. That is your turnaround time. Total how much time you spent in a college, in the college for the day. That is your turnaround time. So turnaround time is how much the amount of time process spends in the system. Suppose at a particular time, 8:10, a process arrived in the system. After that, when the process completed its execution, it is 8:25. So 8:10, it has arrived in the system, and 8:25, it has completed. Total how much time the process spent in the system is 15 minutes. That 15 minutes is its turnaround time. And how do you calculate this turnaround time? 8:25 minus 8:10, that is process का completion time minus arrival time. The word meaning ka is processes. In Hindi we call it as, very tough formula to remember, but you can remember. Completion time minus arrival time is turnaround time for that process. Minus 9 amount of time required, select one. It is not good. It is admitted by the long term. These are the arrival times. At what time you are arriving in the college, that is the arrival time. Process arrives at what time in the system. Arriving means it is admitted by the long term scheduler. Next, now when it is arriving, directly it is going for run? No, it is not going for run. It will be in the ready state. Among multiple ready state processes, the scheduler, short-term scheduler, will select one process to run. But when a process is scheduled to run, for how much time it will run on CPU? Total time required by a process to run on CPU is called as its burst time or service time. How much time it ready state processes, the scheduler, short-term scheduler, will select one process to run. But when a process is scheduled to run, for how much time it will run on CPU. Total time required by a process to run on CPU is called as IM, and you are 8 to process completion time minus arrival time is turnaround time for that process. Now, when you go to the college for 8 hours, for sure you are not studying for 8 hours. You are studying hardly 6 hours or 5 hours in the classes. Remaining time you are waiting when the lectures will get over, when you will be getting your lunch. In between the lectures, sometime you are spending not studying. Do you do that? Yes, you do that. And that is your waiting period. Waiting time of what? Waiting time of just waiting so that you can have your classes back. Let's say when you get up from morning 8 a.m. you start your classes on Unacademy, and till evening 10 p.m. you attend the classes on Unacademy. But from morning 8 to evening 10, are you attending classes full day non-stop? No, you have some time in between where you are not attending the classes. So what you are waiting at that time, you are waiting for the next class. And when you are waiting for the next class, you are not doing anything, let's say, in perspective of live classes. So that is your waiting time. Now I have calculated total time spent by a process from arrival to completion is this much. In this total time, the process has spent this much of time, burst time, this much of time for execution. If this much of time process is spent for execution, remaining time process was doing what? The remaining time process was waiting. For what? Waiting for CPU. Where? In this ready queue. Just because we have more than one processes, of course. For what? If this much of time process is spent for execution, remaining time process was doing what? The remaining time process was waiting. For what? Waiting for CPU. Where? In this ready queue. Time process was doing what? Time spent by a process from arrival to completion is this much. In this total time, the process has spent this much of time, burst time. This from arrival to completion is this much. In this total time, the process has spent this much of time, burst time. This much of time for execution. If this much of time process is spent for execution, the remaining time process was doing what? The remaining time process was waiting. For what? Waiting for CPU. Where? In this ready queue. Just because we have more than one processes, of course, every process cannot run at a time in the running state. Yes. So most of the time, what will happen? One process runs, remaining process waits. So waiting. For what? Waiting for CPU. Where? In this ready queue. Just because we have more than one process. Of course, every process cannot run at a time. In the running state. Yes. So most of the time, what will happen? One process runs, remaining process waits. So for how much time a process waits for CPU, that is its waiting time. I'm writing the definition. Waiting time is what? Amount of time a process spends to wait for CPU or spends in waiting for CPU. And this waiting time you will calculate by in total turnaround time subtract burst time. These are the two formulas we will use to get the average things. These are the two formulas we will use for our calculations in the questions. But this is not it. There are a few more things which we need to know. One is response time. Response time is what? I did not bring my water bottle. You need to wait for a few seconds. Thing. There is no. You read the definition, you will get every single thing. There is no any tough thing in this particular slide. Everything is written over here. Once we will solve the question, you will get more idea of all these. First, next thing is response time. What is the response time? The response time is nothing but whenever a process arrives, from there how much time process needs or how much time is needed by the system to get the response out of the process. Response means whenever the process will start executing, its first responses will come, right? So response time is nothing but time from arrival to or response time is nothing but whenever a system to get the response out of the process. Response means whenever the process will start executing, its first responses will come, right? So response time is nothing but time from arrival to first response of process. You will understand this more in the questions. Once I will explain the question, I will explain this, what exactly this response time is. Okay. Now scheduling length. Scheduling length is nothing but total for how much duration we have scheduled the processes. Scheduling length. Scheduling length is nothing but total for how much duration we have scheduled the processes. And how do you calculate that? Calculation is very simple. Completion time ka maximum minus minimum of arrival time. Again, all these last three things you will understand more when you will get the questions done. Once I will solve the questions for all of you, you will understand every single thing. Throughput. What is the throughput? Throughput is number of processes executed in a or in one unit, or I should say per unit time, ज़्यादा ठीक रहेगा. In 1 unit of time, maybe 1 nanosecond, maybe 1 second, how many number of processes are completely executed. That you will write as n divided by scheduling length. If suppose you are executing n number of processes in total this much of scheduling time, then in one time unit, how much? This much. I will explain this, all these three things in a question. Don't be confused. Your confusion is not a confusion. It's just a lack of information. You will get the information complete once I will go through the question. Don't worry. फर्स्ट स्टेप में सब कुछ समझ नहीं आता. These are the scheduling algorithm we are going to discuss. We have more algorithms based on these, but once you will understand how to solve questions and once you understand how these work, you will be able to solve any type of question. Let's start with the first one, FCFS, first come first serve. Now all the members who are live here, I am enabling the chat. Why? Just because I want you to have the interactive study. Now remember one thing, if you are going to chat, you are going to chat only in the present thing. You are not going to ask, can you please explain again that? Sir, I did not understand response time. Sir, can I take COA lectures from 2.0? How should I study that and this? This is lecture of OS and currently we are studying FCFS. So please talk about that only. Otherwise, because of your such kind of irrelevant chats, I'll have to disable the chats once again. So please remember that. And here it is the chat. Okay, so what is the criteria? Criteria means I'll have to disable the chats once again. So please remember that. And here it is the chat. Okay, so what is the criteria? Criteria means if suppose we are going to have the CPU scheduling implemented based on this algorithm, first come first serve, then in this algorithm, on basis of what we will schedule a process. If multiple processes are there in the ready state, then Then what happens if multiple processes are there? Based on what criteria we schedule the process? On basis of what we will schedule a process? If multiple processes are there in the ready state, then what happens if multiple processes are there? Based on what criteria we schedule the process? Criteria is simple: arrival time. Whichever process is having minimum arrival time, first. Correct? But if two processes are having same arrival time, then we need to have some kind of tiebreaker. Right? What is the meaning of tiebreaker? If two processes are having tie, that they are having same process arrival time, then we need to go with the smaller ID first. Whichever process is having smaller ID. Now you will say, sir, if two processes are having same ID, then I will talk about this, that what if two students will get the same roll number in GATE? Will they get the same marks in the GATE exam? You decide if you can have such kind of system or not. If it is ID number, for sure IDs are always unique. And how will I get, sir, that what is a smaller ID? Then you need to reschool yourself. Just because 1, 2, 3, 4 or ABCD, you understand which one is first. XYZ, something you can easily understand which one is smaller. Okay, chalo. Mode. What type of mode this particular scheduling will implement? Answer is preemptive. No, non-preemptive. Once a process is scheduled, that process cannot be preempted. Non-preemptive. Okay, I will solve a question, very simple one to start with, so that we can understand how to solve the questions and how we will get all the calculations done. Once you will understand one question, I will give you the chance, enough number of chances to get the answers for all the questions. So here it is, the very first question. A process scenario is given. In that process scenario, we need to execute the processes in the FCFS order. To get this particular thing, we need to make a timeline diagram from where to where or when to when which process is executing, and that timeline diagram is called as Gantt chart. Gantt. So here it is, the very first question. A process scenario is given. In that process scenario, we need to execute the processes in the FCFS order. To get this particular thing, we need to make a timeline diagram from where to where or when to when which process is executing. To get this particular thing, we need to make a timeline diagram from where to where or when to when which process is executing, and that timeline diagram is called as Gantt chart. Gantt. A point to remember here, the Gantt chart always starts from 0. Okay, remember that point. Sure. So here is the Gantt chart. This at time 0, we will have to check out that how many processes are arrived in our system. So we need to check out the processes and their arrival times. 3 processes are there. So here is the Gantt chart. This at time 0, we will have to check out that how many processes are arrived in our system. So we need to check out the processes and their arrival times. 3 processes are there, P1, P2, P3. Their arrival times are 0, 0, 0, and their burst times. Burst time means if P1 is scheduled to run on the CPU, how much time P1 will take to execute on CPU, that is the burst or service time. So P1 will take 30 time unit, P2 will take 6 time unit, P3 will take 6 time unit. Okay, at time 0, I'll have to check what are the processes arrived. All are arrived. So among these, which process to be scheduled? I'll have to check. My criteria is arrival time. All arrival time are 0, smaller, smaller, smaller only. Then I'll have to check the process ID. Just because there is a tie in arrival time. Process ID, which one is smaller? P1 is smaller. I will schedule P1 first at 0 time unit. If I will schedule P1 first, P1 requires how much time to run? 30 time unit. Can once P1 is scheduled, I can preempt it because of any reason? No, I cannot. So P1 will completely execute for next 30 time unit? Yes, up to 30. After that, after 30, I'll have to select among remaining processes. Any new arriving process? No. 2 processes are left, P2 and P3. All both are how much time to run? 30 time unit. Can once P1 is scheduled, I can preempt it because of any reason? No, I cannot. So P1 will completely execute for next 30 time unit? Yes. Up to 30. After that, after 30, I'll have to select among remaining processes. Any new arriving process? No. 2 processes are left, P2 and P3. All both are having 0, 0 time unit. If arrival time is same, then I'll have to schedule that process which is having smaller ID, P2. P2 requires how much time? 6 time unit. After 30, 6 more time unit in the timeline up to 36 P2 runs. After that, at the last, I can run P3, more 6 time unit, 36 plus 6, 42. Understood? Okay, now listen. What am I saying? That when this Gantt chart is done, then all the all the algorithms will have the same procedure. Every algorithm will have same procedure. It's just that in what order, at what time, from when to when a process is executed, that Gantt chart will be different for different algorithms. Apart from that, every single thing will be same to same. What we need to do, we need to calculate these three things: completion time, turnaround time, and waiting time. सबसे पहले completion time. I'll have to check in this diagram when a process is completing. Look at this. When P1 is completing, at time unit 30. So completion time of P1 is 30. At what time P2 is completing? 36. At what time P3 is completing? In the timeline 42. Now we will use these two formulas. Turnaround time is total time spent by a process starting from arrival to completion. Look at this. This process P1 arrives at 0 and completes at 30. Total, how much time that process has spent? 30 minus 0, 30. This process P2 arrives at 0 and completes at 36. Total, how much time it spent in the system? 36. This process arrives at 0, completes at 42. This process has spent total time in the system 42 time unit. Time unit can be nanosecond, millisecond, microsecond, whatever they will give in the question. Now look at this. This is the total time. Among 30 time unit, P1 process has spent 30 time unit only for execution. So how much time unit? Time unit can be nanosecond, millisecond, microsecond, whatever they will give in the question. Now look at this. This is the total time. Among 30 time unit, P1 process has spent 30 time unit only for execution. So how much time that process was spending on waiting? Nothing. Turnaround time minus burst time is waiting time. Answer is waiting time 0. This process P2 is spending 36 time unit in the system. In that, running time is only 6. Remaining 30 time, what it was doing? Waiting. 42 is the turnaround time minus 6. 36 is the waiting time. Now what we will have to do is we will have to calculate the average turnaround time and average waiting time. When we talk about processes, in this algorithm, processes spend total how much time on an average. So total around turnaround time divided by number of processes 3, average of 3. How do you calculate? 30 plus 36 plus 42 divided by 3. Answer should be 36. And what is the average waiting time of each process? On an average, 0 plus 30 plus 36 divided by 2. 8 to 0 है ना? So should I divide it by 3 or 2? 3. चलो बेसिक्स तो पता है आप लोगों को. 66 divided by 3, 22. So what kind of question can be asked? Question can be asked, FCFS algorithm, this is the process scenario. What is the completion time of P1? What is the completion time of P2? What is the completion time of P3? Any of these questions. What is the Turnaround time of any specific process. What is the waiting time of any specific process? What is the average turnaround time? What is the average waiting time? Among those, anything can be asked. TAT is turnaround time. Understood this much? Now let's talk about response time. Look at this Gantt chart and this. P1 process arrives at 0. At what time P1 gets the first time CPU? 0. So how much time P1 waited so that at the very first time it can get the CPU? Answer is 0. So response time of P1 is 0. P1 arrives at 0. At very first, P1 gets the CPU at 0. So how much time P1 waited to get the first time CPU? 0 time. That is why its response time is 0. Now look at this. P2 arrives at 0. After arrival, P2 waited for how much time to get the first time CPU? 30 time. So what is the response time of P2? 30. P3 arrives at 0. And how much it waited total to get the first time CPU? 36 time. There is no any formula for response time. That's why I have not given. When you will calculate the response time, we will have certain idea. Once you will learn a particular few things, then we will compare different algorithms and we will try to have some kind of intuitions or analogy that what exactly the response time is. Okay, so what is the average response time? RT, response time. 0 to P so that at the very first time it can get the CPU. Answer is 0. So response time of P1 is 0. Process arrives at 0. Look at this Gantt chart and this. P1 process arrives at 0. At what time P1 gets the first time CPU? 0. P1 is 0. P1 arrives at 0. At very first, P1 gets the CPU at 0. So how much time P1 waited to get the first time CPU? At very first, P1 gets the CPU at 0. So how much time P1 waited to get the first time CPU? 0 time. That is why its response time is 0. Now look at this. P2 arrives at 0. After arrival, P2 waited for how much time to get the first time CPU? Thirty time unit. So what is the response time of P2? 30. P3 arrives at 0, and how much it waited total to get the first time CPU? 36 time unit. There is no any. There is have certain idea what exactly the response time is. Okay, so what is the average response time? RT, response time. (22). In the question, they will give you arrival time in time unit, millisecond, microsecond, nanosecond. This bus time also millisecond, nanosecond, or time unit. Whatever time unit they will give, you will use that time unit to get the answer here. Okay. Any kind of analogy or a statement, etc., we will talk about as whenever we will understand few more algorithm. Okay. Now look at this. What is the scheduling length? What is the scheduling length? Scheduling length of maximum of completion time minus minimum of arrival time. Total for how much duration we have scheduled the processes. Maximum of completion time is 42 and minimum of arrival time is 0. So scheduling length, if I want to calculate maximum of completion time minus minimum of arrival time, 42 minus 0, 42. For 42 time unit, we have scheduled the processes. In those 42 time unit, how many number of processes you executed? So what is the throughput of the CPU? If I have not given here throughput, I will mention as mu. In this case, what is the throughput of the CPU? Number of processes 3 in 42 time unit. So what is the throughput of the CPU? If I have the minimum of arrival time, 42 minus 0, 42. For 42 time unit, we have scheduled the processes. In those 42 time unit, how many number of processes you executed? So what is the throughput of the CPU? If I have not given here throughput, I will mention as mu. In this case, what is the throughput of the CPU? Number of processes 3 in 42 time unit. So what is the throughput of the CPU? If I have not given here throughput, I will mention as mu. In this case, what is the throughput of the CPU? Starting from when to when we schedule the processes. Between 0 to 42, we schedule the processes. Total scheduling length is 42 time unit. That is why maximum of completion time minus minimum of arrival time. Okay, so it's throughput of CPU, that CPU is able to execute 3 processes in 42 time unit. Then hence 1 divided by 14. 1 divided by 14 number of processes per unit of time. Okay, that is the throughput of the process execution. Ayush, will you get any subjective paper? Then now you solve this question. The throughput will be the ratio only, number of processes per unit of time. It cannot be converted into the percentage. It might possible that in 100 unit of time you are executing 120 processes. So 120% is the throughput. Not possible, right? Yes, it's just a throughput, number of processes per unit of time. It's a ratio or just a factor. Solve this question and get me all 3 times. Prepare the Gantt chart. Somebody was confused between turnaround time and completion time. Why? Vandita. Get me the fraction part. You will not write the result in the exam 53/6 if it's NAT type question. At 0 time unit, one process arrives, only P1, schedule it for 5 time unit, up to 5. Now next, at 1 time unit, another process arrives for 1 time unit up to 6. Another process arrives at 2, 2 more unit time, P3, up to 8. Then next arrival is 3, 4 time unit execution, P4, up to 12. Then at 4, another process arrives for 5 time unit, it runs P5 up to 17. Then last at 5 time unit, another process P6 arrives up to 20. TAT क्या होता है? टर्न अराउंड टाइम इज टोटल टाइम स्पेंट बाय अ प्रोसेस. Here is the definition. You joined us late, that's why you are having confusion. Vandita. Total amount of time process runs or process spends in the system from arrival to completion. Completion time minus arrival time is the formula. Okay, so completion time. Quickly, let's write down all the numbers. Completion time of P1 is 5. Completion time of P2 is 6. P3 is 8. P4 is 12. P5 17. P6 20. How do you calculate turnaround time? Completion time minus arrival time. 5. 5. Not 5. Calculate turnaround time. Completion time minus arrival time. 5. 5. Not 5. 4. We have 4. Completion time minus arrival time. Okay, 5. 6 minus 1. Okay, 5. 8 minus 2, 6. 12 minus 3, 9. 17 minus 4, 13. And 20 minus 5, 15. Waiting time. How do you calculate waiting time? Turnaround time minus burst time. 0, 4, 15, and 20 minus 5, 15. Waiting time, how do you calculate waiting time? 5. Oh, not 5, 4 भैया 4. Completion time minus arrival time, okay, 5. 6 minus 1, okay, 5. 8 minus 2, 6. 12 minus 3, 9. 17 minus 4, 13. And 20 minus 5, 15. Waiting time, how do you calculate waiting time? Turnaround time minus burst time. 0, 4, then 4, 9 minus 4, 5, 13 minus 5 is 8, and 15 minus 3, 12. Response time should be like this. Can you please confirm? Are you getting same to same or not? Chalo, average. Should be like this. Can you please confirm? Are you getting same to same or not? Chalo, average. Average turnaround time. How do you get average turnaround time? Addition of all 10, 26, 27, or no, 37 and 10, 47 plus 6, 53, 53, 53 divided by 6. 48, 50. 3 आना चाहिए. 18. 3, 3. Response time once again. Okay, let's check it out. P1 process arrives at 0. And getting the first time CPU as 0 only. So it is taking response 0 time. P2 arrives at 1, but getting the first time CPU at 5. So how much time it is waiting to get the first time response? 4 time unit. P2, P3 arrives at 2, gets the CPU at 6. So response time is 4. Arrives at 3, gets the CPU at 8. How much time? 8 minus 3, 5. Arrives at 4, gets the CPU as 12, response time 8. Arrival time 5, gets the CPU at 17, 12 is the response time. Right now it is equal, but we will check out later on. I'm not giving any kind of statement as of now. Okay, average waiting time. Kitna hua? 33 by 6. 5.5. Average response time. Same. 5.5. Good. What is the scheduling length? Maximum of completion time minus minimum of arrival time, 20. And what is the throughput? Number of processes, 6 divided by 20. 0.33 processes per unit of time. Cool, clear, understandable. Another question. Do it. Sriparna, we will make this kind of statement little late once we will understand what is the preemptive scheduling and how we will calculate the response time. I told you whatever the statements you are making, don't worry about that. Such kind of all the statements I will tell you. Okay, all those members who are not understanding the response, have you ever went for shopping to the shop where you'll have to give the order to the shopkeeper? Some kind of general store or kirana store or something. So suppose you have arrived at shop at 10 o'clock 5 minutes and you waited for 2 minutes. After that somebody came to you and asking you what do you want, क्या चाहिए आपको, बोलिए मैडम, बोलिए सर क्या चाहिए, क्या देखेंगे आप, what do you want? So how much time you waited to get the response from the shopkeeper for the very first time? 2 minutes. That is your response time. How much time the shopkeeper is taking to respond to you after looking at you or after you arrives in the system? That is the response time. But that doesn't mean that after that you will not wait in the system. You may wait for the later part of time also. Yes or no? Yes. Might possible the shopkeeper has gone to bring lots of items for you in the other go down or something. Now you understand what is the response time. Balvindra, again I am telling you, do not make such kind of statements. I will tell you what are the statements once you will learn the further things. रविश, मैंने समझाया ही नहीं तो समझ में कैसे आएगा? जब हम समझाएंगे तो समझ में आएगा. Do not make your mind running in multiple directions. Rather, whatever I am asking, do that particular thing. Whatever those different kind of statements, analogy you are making, I will tell you how it works. No problem. Let's prepare the Gantt chart. Gantt chart starts from where? 0. We will check out in the system, do we have processes arrived at 0? No. At time 0, no any process arrived. So at what time the very first process is arriving? At time 2. Which one? P5. So from 0 to 2 time unit, will there be any execution in the system? No. So what CPU will do? CPU will be idle. At 2 time unit, which process arrives? P5. So can we give the CPU to P5? Yes. How much time unit? 2 time unit. So P2 runs, sorry, P5 runs for 2 time unit up to 4. Up to 4, how many processes are arrived? Check it out here. How many processes arrived up to 4? Only one process at 3 time unit, and it requires 1 time. Okay, so let's run that P4. When we will run P4, it takes 1 time unit up to 5. Up to 5, do we have any other process arrived? Yes. Which one? This P1 at time 4. So P1 will run for 1 time unit more up to 9. Then up to 9, do we have other processes arrived? Yes. P3 arrived, P6 arrived, and P2 arrived. So first of all, P3 we will have to run just because it arrives first. P3 runs for 3 time unit 12. Then P6 runs for arrives first. Up to 9, do we have other processes arrived? Yes. P3 arrived. P6 arrived, and P2 arrived. So first of all, P3 we will have to run just because it arrives first. P3 runs. P3 arrived. P6 arrived, and P2 arrived. So first of all, P3 we will have to run. Then up to 9, do we have other processes arrived? Yes. P3 arrived, P6 arrived, and P2 arrived. So first of all, P3 we will have to run just because it arrives first. P3 runs for 3 time unit 12. Then P6 runs for 12 plus 7, 19. And after that, P2 runs for up to 21 time unit. Now rest of the things too you can calculate easily. No? Yes. Let's do it quickly. Completion time. What is the completion time of processes? Where P1 completes, look at this. Do not go with the sequence P1 at 4, P2 at 5, P3 at 9. ऐसा ना कर देना. देखो जरा. Look at this. P1 completes at 9. P2 completes at 21. P3 completes at 12. P4 completes at 5. P5 completes at 4, and P6 completes at 19. Your small concentration loss, 2 marks gone. Sir, why not P2 after P1? What is Ayushi? Oh, sorry, Ayush. What is the arrival time? We are running FCFS algorithm. FCFS algorithm is using first come first serve. Whichever arrives first should be scheduled first. Don't do not make a joke out of it. My wife's name is Ayushi. I am habitual to name her a lot. Ayush ko Ayushi pad liya maine. Okay. Okay. So what is turnaround time? Turnaround time. Completion time minus arrival time 4. 21 minus 8 is 13. 12 minus 6 6. 5 minus 3 2. 4 minus 2 2. 19 minus 7 is 12. Good. Next, waiting time. Turnaround time minus burst time 0. 11. 3. 1. 0. 5. Response time you will get as waiting time only. You can calculate. Average. Average turnaround time 39 by 6.5. Average waiting time will be equal to 20 by 6, 3.33. Average response time also same to same. Yep. What is the scheduling length? Maximum completion time 21 minus minimum arrival times 2. It's not 0 this time, 90. In the 19 time unit, you have scheduled the processes. Starting 2 time unit, no any scheduling. Okay, so answer is 19, and in those 19 time unit, how many processes you executed? 6. So 6 divided by 19 is your this. Now look at this. In this, is there any period where processes are not executing, any idle period of CPU? No. So total how much time you will be spending for CPU execution? Total 20 time unit. All the time unit, 20 time unit. In those 20 time unit, you will execute all the processes? Yes. To cross check that we did not have or we did not do any kind of calculation mistake, you just take the summation of all the burst times. P1 runs for 5 time unit, P2 runs for 1, P3 runs for 2. Total how much CPU time required to run all the processes? 20 time. Time. So total how much time you will be spending for CPU execution? Total 20 time unit. CPU. No. So total how much time you will be spending for CPU execution? Total 20 time unit. All the time unit, 20 time unit. In those 20 time unit, you will execute all the processes? Yes. To cross check that we did not have or we did not do any kind of calculation mistake, you just total 20 time unit. All the time unit, 20 time unit. In those 20 time unit, you will execute all the processes? Yes. To cross check that V time unit P2 runs for 1 if no any ideal period is there. If idle period is there, how much summation of this plus idle period 2? Summation of this you can just know 20 plus 9, 19, sorry, 10 plus 9, 19, 19 plus 2 is the idle period, total 20 time, 21 time unit is your Gantt chart runs. So that's a cross check you can have so that you can easily understand while, writing these, you did not make any kind of mistake. Sometimes it happens. 19 plus 4 is equal to 21. 17 plus 4 is equal to 23. Such kind of small calculation mistake are easy to be done. There are, yes, happens. Scheduling time is equal to sum of burst time of all processes minus this idle period if you have initially idle period. When there is no any idle period, it will be same to same. Scheduling length will be equal to this last 20 total. Okay, now let's go ahead. Let's learn few more things. Yes. There is a problem in FCFS called as convoy effect. What it is? There is a signal. On that signal, there is a traffic police, a person who selects who will go ahead with this particular path. There is a path on which vehicle can run, but only one vehicle can pass through this particular path at a time. Means no any two vehicles can go in parallel. Hence, of course, there is no any chance on this particular path to have overtake. No any overtake. One by one only this particular complete path of, let's say, 20 kilometer or 40 kilometer can be crossed. Now on this signal we have two vehicles. One is a fast moving car and one is a slow moving truck. Car is having average speed of 80 kilometers per hour and truck is having speed of 20 kilometers per hour. Now, if on this signal both are standing, this traffic police who is standing on this particular signal selects that, okay, truck, you go ahead first and then car will go next. In that case, the speed of car will be slowed down. Why? Just because it is following the truck. So if truck is moving slowly, then this car and further all the vehicles which are following this particular truck, entire convoy will be slowed down because of this slow moving truck. Yes, happens. Yes, happens. You might have seen so many such examples that one auto is running through and trying to come on a particular this slope. Some kind of overbridge is there and trying to climb that overbridge with 15 kilometer per hour, and all the vehicles are just following that particular small duk, 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 duk. Why? Just because that is so slow, cannot climb, we cannot have the overtake, all the vehicles are getting slowed down. Happens? Yes, that is the convoy effect. So what is exactly convoy effect? Convoy effect is if a larger process means the process which takes lots of burst time, a large burst time. If a large process is scheduled first, then remaining all other processes which are fast means having very less burst time will have to wait for a very long time, and because of that system's performance will become slow. That is convo effect. It can be seen at doctor's office also, or at some places also, like at any shop, at anywhere. Suppose there is a doctor's appointment, three fellas are sitting, three patients are sitting, P1, P2, P3. P2 and P3 will take only one minute of time to see the doctor and just check few informations. P1 takes, let's say, 1 hour of time, and if compounder or the selector who is sitting here, the person, he selects that P1 patient, you go inside, these two will wait for 1 hour to complete their 1 minute of task. It's a convoy effect. Their waiting time is too large, but their execution time is very slow, very less. Hence, entire system's performance becomes very slow because of this large process. Everywhere wherever you are having a line, first person is taking too much of extra time. At ATM machine, person is taking too much of time to take the withdrawal, or multiple withdrawals are happening. At mall, if person is taking too much of time for the billing, everywhere it happens. You are in the toll line and the person is in the wrong line, that fellow is not in the fastag line and getting their cash done. Cash is not having the accurate change, is not there, and there are lots of examples. So what happens, the slow process is scheduled first, because of which, if the the slow moving processes scheduled first, because of that fast moving processes will have to wait a lot. Look at this. In this example also we had convoy effect. Look at that. Three processes arrived at 0, but we scheduled this process first. Look at this. P1 ka waiting time. Okay, fine. But P2 ka waiting time is how much? P2 waiting time is 30. Execution is just 6. Waiting is too much. P3's waiting time 36. Execution is just 6. Too much. It makes our system slow, and that is convoy effect. So what is convoy effect? Oops. I can't do this, Control Z. Okay, no. First of all, only FCFS, convoy effect, process first. Yes, this is because of non-preemptive nature. The process which is fast moving, so that the system will not become slow. Fast car, yes. And that is what we are going to do in the next algorithm. Next algorithm will try to schedule, to overcome this problem. What we can do, we can schedule that process which is the smaller process. Hence, that is the another algorithm we are going to discuss. Okay, so to solve this problem, we will try to schedule that process which is having the least burst time, and that is another algorithm to solve this problem. Laksh, nothing, no any prerequisite. So what is the problem in FCFS, or what are the advantages? First of all, advantages, it is easy to implement, so no any complex logic to be implemented. Based on the arrival, we can schedule the processes. No any starvation is there in this FCFS. Starvation is what I'll talk about later on. Advantage, done, no disadvantage, no any option of preemption, first of all. Second is convoy effect, makes the system slow. These are the two disadvantages we are having. Okay, what is the starvation? I'll talk about that later. Because no, it's not correct. Okay, so to solve the problem of this convoy effect, we are going to go for the next algorithm, shortest job first. In this algorithm, we will try to schedule that process, which this one, if we don't have much time here to make your notes, okay? You take the snapshots quickly so that you can write the notes later on. If I'll give you lots of time for making the notes, it will be difficult for us to cover up the things. So what we are trying to do, we are trying to schedule that process which will take minimum burst time. So criteria for scheduling in this algorithm is burst time, minimum burst time first. But it might possible that few processes are having same burst time. Yes, then tiebreaker is required. Yes, what is the tiebreaker? Tiebreaker is FCFS. You know how to do FCFS? Yes. In FCFS, we'll have to check the arrival time. If processes are having arrival time also same to same, then PID, you know that. How to do the FCFS, abhi maine samjhaya. First of all, check the arrival time. If arrival time is also same, then PID. Mode of this algorithm is non-preemptive. Chalo. Let's solve the same question now with this SJF. First of all, which process to schedule based on the burst time? Burst time, minimum burst time. Two processes are having minimum burst time. If tie, then go for arrival. Oh, arrival is also zero. All are zero. If arrival is also zero, then process ID. Which process to be scheduled first? P2. Now, few may ask, sir, can we schedule P3 first? Then please check out this. Okay, so P2 runs for how much time? Up to 6. Then remaining are these P1 and P3. Which process to schedule next? Minimum burst time P3 up to 12. After that, slow moving process P1 up to next 30 time unit up to 42. What is the completion time of P1? 42, P2 6, P3 12. What is turnaround time? Completion time minus arrival time 42, 6, 12. Waiting time 42 minus burst time 12, 0 and 6. Average turnaround time. How much? (42) and 18, 60 divided by 3, 20. Average waiting time. 12 plus 6, 18 divided by 3, 6. Average response time. Response time is also 18 by 3, 6. If not, then you can write it here. Response time also it will be 12, 12, 0 and 6. What is the scheduling length? And what is the throughput? 3 divided by 42. Same question we have solved with FCFS. What was the average waiting time? 22. Turnaround time 36. 36 and 22. Now, how much we are having? The same one. Oh, actually, Jira. Look at this. 20 and 6. Too much of time we have saved. A lot of time we have saved. Throughput is same to same. Yes, same number of processes we are executing in total same time. That's why throughput is same to same. So can we say waiting time is less here? Yes. Both are better. Yes, of course we will have. Okay, so one question you solve for me then. Sanket, it's just a theoretical study, so we cannot know in the practical for sure. थोड़ा हिंट दे दो टाइम से. SJF is non-preemptive. अभी तो बोला. First of all, if you are getting any of these times as negative, that means you are getting something wrong. A process spends -6 time unit or -4 time unit in the system. Waiting time of a process is -2, cannot be possible. So think about that, okay? Okay. To explain this shortest job first and its preemptive version, I'll have to take one example. All those people, whoever doing whatever right now, just stop your calculation and let's try to understand this with a very simple example of cricket. Why? First of all, if you are getting any of these times as negative, that means your process is -2. Shortest job first and its preemptive version, I'll have to take one example. All those people, whoever doing whatever right now, just stop your calculation and let's try to understand this with a very simple example of cricket. Why? Just because I love cricket. And I got very beautiful example created for all of you so that you can understand how this works. So look at this. Uh, you might have played cricket a lot. If not, then at least you can relate with this example. There is a cricket match you have taken with, you have conducted or you have scheduled with one of the team in your town, maybe in your school, college, wherever. And you thought ये तुम्हारे इसी हरकतों की वजह से ना गेट में रैंक नहीं आएगी, समझ लेना। मैं बात कर रहा हूँ समझाने की, तुम माही माही कर रहे हो, माही तुम्हारे को रैंक नहीं दिलाएगा, है ना? पढ़ लो पढ़ लो, सही बोल रहा हूँ। जस्ट स्टडी एंड फोकस ऑन लर्निंग. So suppose that your opposition team entirely is on the ground, but you know your best friends and your teammates, your friends, they are all lazy. So you are at the ground, and along with you, one more person is there on the ground at 6 a.m., that pre-decided time. Now let's say you decided to have a toss, you won the toss, now you decided to bat first. Now what happens? How many people are there on the ground to play along with you in the batting? Only one. Now let's say this fellow won, the other person, let's say other person is your one friend, friend number F1. That F1 is not too great to play at initially. You will not give this particular fellow a chance to bat along with you. but you don't have any option just because your best batters are still not yet on the ground. So, to whom you will schedule to bat? You don't even know those fellas will come on the ground or not. So, you don't have any option, but you will have to give the chance to play F1. Let's say you have given the chance along with you is your one friend, friend number F1, but you don't have any option just because your best batters are still not yet on one friend, friend number F1. That F1 is not too great to play at initially. You will not give this particular fellow a chance to bat along with you, but you don't have any option just because your best batters are still not yet on the ground. So, to whom you will schedule to bat? You don't even know those fellas will come on the ground or not. So, you don't have any option, but you will have to give the chance to play F1. Let's say you have given the chance along with you to play on the ground F1, and after just 1 minute, another fellow comes. That fellow is a better batter than F1, but you cannot preempt F1. You cannot ask F1 that you go out and I will ask other new arriving person to come on the ground. Why? Just because you and opposition team decided that no person can be retired because of any reason until that fellow will get out. That fellow is scoring slow and you will feel like I will lose the game. But you can not make this F1 go out of the ground. You cannot preempt that fellow. Yes. And that is what SJF. So at time zero, I'll have to check what are the processes arrived. My best process, the fastest process, which takes one time unit, is not yet arrived. This also not arrived. This also not arrived. This also not arrived. This also not arrived. Only one process arrived, P at time zero, slowest one, but I do not have any option. I'll have to schedule P1 only up to 6 time unit. You will have to schedule only those processes which are arrived.